what is exception? First thing, so let's see what is exception. Exception means at a runtime, suppose we get any abnormal situation of the program, and because of that, program is aborted. That means it process just killed forcefully. Okay, so this is an because of the abnormal situation or something is wrong inside the program at a runtime. So it is a runtime errors. We say it's a runtime errors. So what is the difference between the compile time error and runtime error? Compile time error means compiler checks at the time of compilation, that is your source code, whether your source code is according to the rules. That means the syntax and whatever keywords you are using into the program, these are properly mentioned. The spelling, case sensitiveness, etc. is checked, and if the compiler passes your code successfully, then it creates object code. But at the time of execution, so there is no role of compiler. At that time, the runtime environment will execute your object code, and at that time, if your program is dependent on any other files, so in that case, or external resources, so in that case there may be the problem to access those resources, because your source code is depends on any other situation, any other resources, and you cannot give and guarantee whether the other resource will work properly. So at a runtime there may be any abnormal situation, and because of that your program will not work properly, and your program hangs, or it aborts, or it kills, your process kills. So how to deal with that error and how to continue the flow of execution after skipping that type of instructions? It is nothing but the exception handling. So exception is the runtime errors, and exception handling to deal with the runtime errors. Okay, so just see the theoretical part first. So exception are required to signal serious problem when a program is being executed, and exceptions are required to signal some particular unusual event in the program that deserves a special attention. For example, suppose you are working on a file handling. At that time, if the end of file has been reached, and then file has been corrupted, or file is not found, or file is not available at respective location, so it may be any type of error, right? And we have to focus on that type of error. It is not related to your Java source code, because file access, that file path or file is corrupted, it depends on that file, that is external resources, right? And if it is not accessible, or it is not available at a respective location, or it is corrupted, so definitely your program will not work and your program aborts, right? So we have to, in that situation, we have to identify what is exact error and just try to resolve that error, and then continue the flow of execution, right? So that is exception handling. Now let's see exceptions in Java. Specifically, these are objects. Okay, that means the hierarchy, inheritance hierarchy is available for exception handling, and all objects, these exceptions are available in the form of objects. That means these are classes. So it's a very huge hierarchy. I will show you using the block diagram of exception handling, and it is having a category, that is the checked and unchecked exception, and certain rules to use those checked and unchecked exceptions. So we will see one by one. So now exceptions handling is an object-oriented way of handling the errors, runtime errors in Java, and then keep problem solving and error handling code different. That means if you are dealing with exception handling, then the exception handling code is a specific code which handles the runtime errors, and we have to keep it separate. Okay, thus the program is less complex because code maintainability will be easy in that case. Exception in Java are actual objects, and object encapsulate the error information. That means it returns you the exact error information, what is the error information when you are dealing with those errors. Exceptions are created when an abnormal situation arises in the Java program. Now look, this is the very important and useful diagram. I hope this is visible to you. Is it visible clearly? Now look at this is the inbuilt classes available in a Java API which is related to the exception handling, and, this is available in your language package, java.language package. All classes are available in that java.language package. In this diagram, in this block diagram, the different color combination is used, and every color combination, the blocks are having specific meaning, and that we have to understand. This is important. Okay, now just go with the first class, that is a throwable. So it is a class, it is not an interface. In a Java, the other interfaces are start with the able, that ends with the able, that like a throwable, clonable, serializable. These are interfaces, but throwable is a class. So that is it is specifically, I am telling you, it is a class, it is not interface. Okay, other clonable, serializable, these are the interfaces. So where is the able label available? Most of the interfaces are available in Java, but throwable is a class. Now throwable is a super class for all exceptions and errors. Okay, now this is also a runtime error, and this is exception. So what is the difference between this error and exception? This is a error class, and this is your exception class. Both are exceptions. Okay, now exception means what? Runtime errors. Both are runtime errors. Only the thing is, error is a class available, exception also class available, and the hierarchy is like this. Error and exception are the children of throwable. Okay, so exception is a throwable, error is a throwable. So exception you can throw, error also you can throw. Okay, next, exception having now number of children. Look here. So now allow part, that is allow blocks, these are nothing but the checked exceptions. So look here, it is a checked exceptions. Okay, and this is your orange part, this orange part, runtime exception. These are your unchecked exception. It is known as a runtime exceptions also. Okay, so look here, it is a runtime exception. Now what is this IO exception? It is a class. Class not found exception, it is a class. Class not supported exception, it is a class. End of file exception, it is a class. File not found exception, it is a class. Malform URL, it is a class. Unknown host exception, it is class. Again, more classes are available. Because of the limitation of this diagram, we cannot include all classes, but this is under a category of the checked exceptions, and all are classes. Classes means all are in the form of objects. Okay, so you can, if it is a class, you can create object. Or all orange color classes, these again runtime exception, it is a class. Null pointer exception, index out of bound, then illegal state exception, illegal argument exception, class cast exception, arithmetic related exceptions, number format exceptions, array index out of bound. These are runtime exceptions. Okay, so why it is categorized, I will tell you. And another category is available, that is a pink color, that is your error. So it is it's a faint violet pink color, right? Now it is error. Now errors thrown by JVM. So who deal with the error? It is a JVM. And who can deal with the exceptions? We can deal with the exceptions. We can handle using try catch block, and we can continue the flow of execution. It is possible. Okay, errors are related to the specifically memory related errors, like stack overflow, out of memory. Suppose at the time of program execution, you are writing, you have suppose written the program to read the billions of records, and you are storing into the array, and this is dynamic array, and suppose your heap memory is not sufficient. So in that case, definitely after some certain scanning of the records, there is an error. Your program will stop and it gives you error, the out of memory, because we don't have that much memory to in our main in a heap section, right? So in that case, we have to identify that error and we try to resolve it. If it is not resolved, then we have to apply some different approach. First read 50,000, then 50,000, is like this, or you can go with a parallel approach. But that is a different part. But that type of errors are the handled by the JVM. It gives a specific type of error. So this part is related to the JVM, and this is we can handle, and JVM will help you to fire that error. Okay, now what is checked and unchecked exceptions? checked exceptions are not ignored by the Java compiler, and unchecked exceptions, that is uh, now, is it visible? Okay. Now what is checked and unchecked exception? That is important part we have to just clear. Uh, when we are writing the program in a Java where our Java program is dependent on the external resources, in that case Java will not take the guarantee of external resources, whether that external resource will be available at a runtime or not. And that's why these type of exceptions are already checked in Java, and Java compulsory tells you you have to write the try catch block before compilation. That means you have to write that try catch block within a program, those kind of exceptions, because Java will not trust on the external resources. For example, file handling. In a file handling, your program, your Java program is depends on the on that file, and file is not the resource of the Java, it is external resource. Okay, so file may be present on your machine, file may be present in a network, file may be present in a web URLs, right? And Java will not trust whether that URL is right or wrong, right? So for that Java given you the option, you have to provide a try catch block compulsory for your program where you are accessing those files. For that source code we have to provide try block, and within a catch block you just test the statement, what is the exact tracing error statements like print stack trace, etc. So what basically helps you when you write such kind of thing is, when you write the program and if at a runtime error occurs, so definitely it shows you the proper error with the line numbers, where is the exact problem. Okay, and from that the code you can easily that means error you can easily find out and you will try to resolve it. Okay, in a runtime errors, it is not necessary to write a try catch block within a program, and these runtime errors are related to your Java application. For example, arithmetic exception. What is the problem in arithmetic exception? Suppose you are doing the like a divide by zero. Okay, divide by zero, it is the actually problem of your instruction, right? It is a Java problem. So Java cannot resolve such kind of arithmetic expression. That's why it is arithmetic expression. In that case, suppose you are not providing try catch block, then also JVM will throw an error. Okay, but in this case, if you are not providing try catch block, Java compiler will show you error. In this case, if you are not providing try catch block, that means for a runtime errors, Java compiler will not give you any type of error. Java compiler will compile the program at a runtime, whatever exception will occur, program will abort, that exception will show on a screen. But in a checked exceptions, before to compile code, we have to provide a try catch block. Otherwise, if you forget to provide a try catch block, your program will not compile. Okay, so for a checked type of exception, it is a compulsory to write try and catch block. For the runtime exception, it is not compulsory to write a try and catch block. So these exceptions are already checked, these exceptions are unchecked. These are the runtime exceptions. Now the hierarchy is like this. Array index out of bound exception is a index out of bound exception, and index bound out of bound exception is a runtime exception, and runtime exception is a exception is a throwable. So look the hierarchy: topmost throwable, then first level exception, second level runtime exception, third level the index out of bound, fourth level is array index out of bound. So array index out of bound means what? It is a specific one. It is related to the array where you are accessing the element, but that index is not available. Suppose your array having 10 elements and you are trying to access the 11th index, 12th index, 13th index. that index is not available, so how you can access it? So it is index out of bound exception. So your index range is out of bound. Okay, so this is already class is available inside the Java who works on the array index, and we have to just provide, where we are dealing with the array code, we provide that source code in a try block. And if at a runtime, suppose your instruction which takes the element which is not in index, at that time definitely exception will generate. That exception is tested in a try block, and that is fired to the catch block, and catch block will provide you the specific the specific error message, and after that error message the remaining instruction will execute. So why we handle the exception? Because your program execution will continue. So in a C++ also, why we handle the exceptions? Your program will not abort abnormally. Your program will, when you provide the exception handling, your program will display a proper error message on the screen, and after that the remaining instructions will execute. Okay, so it depends how you write the try and catch block. So there are certain rules and hints to write the try catch block. I will tell you that also. Okay, so is there any doubt related to the checked and unchecked? I will show you the code also, one by one we will go, but still if you have a doubt, sir, how these exception hierarchy is available, or we are not getting anything, or it is little bit confusing, then I can answer you. Is there any question? It is very important, and for this definitely upcasting concept will work, and I will show you that how it works. Is there any problem? Is there any doubt, or you want to discuss more on this diagram? No doubt. Can I go further? Okay. Now just look here, exception hierarchy. Already this diagram and this diagram is the same. Only the color combination is available in this diagram. This is more helpful. Okay, the same diagram is available here. Look, throwable having error class and exception. All are classes, all are objects in Java. The class throwable and some of its subclasses. This is the summarized way. Okay. So IO related exception having end of exception and socket exception. This is the again subclasses. So I want to go with the error. Now just go one by one. Error. What is error class? Error describes an internal error in the Java runtime environment. Describes the resource exhaustion in a JVM. And errors are rare and usually fatal. That means you cannot deal with those errors. It's a fatal means, suppose your main memory having the specific size limit, on that specific size limit you cannot go, right? Because this is a hardware problem. How you can go more than that size? So this is, you cannot deal with those errors. Only we have to just find out that errors, and we have to apply the logically approach into our program to sort out it. Hardware issues, it is like a fatal errors. Okay, like out of memory error and stack overflow error. Stack overflow we can, some certain extent we can handle it, but out of memory we cannot deal it. Only we can do one thing in a JVM. So I will tell you, in a JVM the heap section, that is the memory part of dynamic memory part, that heap section, the by default some memory is allocated, size of memory is allocated, and that size is not the complete size of your main memory. That means whatever the size is available to the JVM. So we can increase that heap size also in certain extent using the commands. Okay, so JVM having a command to increase the heap size, and using that command you can do it. In Eclipse, in eclipse.ini file, the last instruction is available. That instruction is related to your memory size, so you can expand that memory size. Suppose by default it is 1024, then you have to go with the 2048. Okay, yeah, that is MB, and that size is applicable to your JVM heap section. Okay, and for related to that, the some kind of memory errors you can solve it. Okay, but out of that you cannot increase it. Suppose your main memory size is a 2 GB and you are trying to give it a 8 GB, so it is not possible, right? Okay, so errors, these are the rare and usually fatal. Now runtime exceptions occurs due to the programming error. Look at this, is the Java related errors. Okay, so it is a programming error and that is not a robust code. It's a simple straightforward, some by mistake you have written, and because of that logical things are wrong, and because of that this error occurs. Like you are trying to cast the data, or you are wrongly putting numbers into the wrong data type. Okay, the mathematical operations are wrong. So like those errors are the runtime errors. Okay, like look at bad cast, out of bound array access. Like your array size is 100, you are trying to access the 101 or 115 or minus index, so it is a wrong access, right? Null pointer access, null pointer access is the usually comes this error. Null pointer access means if you create an object of class, at that time usually um, the wrong practices, students are familiar with the C++ code and they are trying to create an object like a C++, class name and variable name and then semi-comma, and that variable you are trying to access, using that variable you are trying to access the methods of a class like a obj semi-comma and obj dot method 1. Suppose you do like this, a obj in a Java is a reference variable. The obj is not an object, it's just a reference variable of a type A. The object is not created there, only the reference variable is created, and that object is not pointing to, that variable is not pointing to any object, any memory location of the object. That means your pointer, that is obj pointer, is pointing to the null location. That obj pointer is not having any object. Okay, and that's why when you go with another instruction obj dot method name, obj is a reference variable, it is not pointing to any memory, and that's why method 1 is cannot call in a Java. That method 1 get, it will not give a call. Okay, so it is shows you the exception, it is a null pointer access, null pointer exception. You try it in a simple program, no need to provide try catch block, directly create a variable, just don't create a new operator, that a obj semi-comma and obj dot method name, create a class A, create a method A, and try, just run the program, get the error. Okay, so it is a null pointer exception, it is common error. Index out of bound is also common. Okay, so in that case your program aborts and it shows on a screen. So in that case, who gives you this type of error is JVM. Definitely JVM gives this error message, runtime error message. Okay, non-runtime exceptions, that is your checked exceptions, occurs due to the problem in the environment settings. Includes such a problem trying to read a past the end of file, the trying to open a malform URL, that means the URL is wrong. Suppose database connectivity, suppose Java program you want to connect to the database, and whatever database URL is available and that URL is wrong. First scenario. Second scenario, suppose database URL is correct but username and password to access that database is wrong. So Java will not give a guarantee whether your database connection will work properly or not. It is depends on the hard-coded strings of a database, right? And there what Java suggests you please provide try catch block. If any error occurs at a runtime, we will inform you. That means error message will be shown properly on a screen line by line. Okay, that's why these type of non-runtime errors are nothing but the checked exceptions. Okay, and end of file exception, malform URL exception, IO related exceptions. Okay, multi-threading related exception. Multi-threading means it is a operating system part. So Java is depend on an operating system, and threads are created, or how the memory is accessed, how the memory is allocated for multi-threads. This totally depends on your operating system. So Java will not take a guarantee whether your thread will work and which thread will work first. Correct? At certain level you can write the logic in a program, but the execution of the threads are totally based on your operating system, and in that case you have to deal with those errors using try catch block. Otherwise Java compiler will give you error, and if you provide try catch block, then your code get passed, and at a runtime if any error occurs, it will resolve. Okay. Next, if we want to handle the runtime errors or the exceptions, any type of exception, maybe it is checked or unchecked. So in that case, the code you have to write in a try block. Okay, try block. That means suppose you are not having guarantee whether this code will work or not. That code you have to write here in a try block. And for a catch block, you have to give here object. That means which type of error is this. If that error occurs at a runtime, so here error detects, error is thrown from the try block and it is returned to the catch block, and catch block having specific type of catch, or it may be generic, and then here catch block will print the error, what is the type of error, using the your thrown exception object. So whatever error is thrown by you, it is thrown to the catch block, and catch block will print here. Okay. Another block is available, it is a finally. So finally block, basically it is used in a scenario where you want to execute certain instructions at any cost. That means at any situation, whether the exception will generate or whether the exception will not generate. Okay. For example, again we will take example of file handling and database connection. Suppose in a try block you are having file handling code, file open, file reading code, and file will write some data. Okay, and code will execute properly, no doubt. And suppose here you are writing the instruction file object dot close. Okay, suppose your code will execute properly. In that case, the final instruction will execute, that is a file close. But suppose after second instruction your code generates exception. Obviously here suppose exception generates, then it jumps to the catch block. After second instruction, code will not execute. That means file closing instructions will not execute. Exception will generate, come to the catch block will execute, catch block will show you error, where is the error, but still your file object is in opening state. Is it okay? Because the file closing instruction is not executed. And at same time, suppose any other resource or any other program is accessing that file. So for that program or for that resource, your file is not in opening mode, because already your file opening mode is available for this program. So simultaneous write access is not available, read access is available. Okay, so it is a lock, it is a locking situation. So maybe your operating system having some concepts like a deadlock situation, right? Critical monitor, etc., etc. So similar concept is like this. So your file writing situation is not available in that case, and but here the exception occurs. That means here also you are not using that file, and you are putting a lock on that file, and other program also cannot utilize that file. Then this is the logical bug of your program. So in that scenario, what you have to do it, you have to provide a finally block, and here you write that instruction file dot close. Okay, file instruction dot close. So what will happen when you write a finally block, whether exception occurs or don't occur, finally block definitely executes. Okay, 101% finally block will execute. So obviously finally block, you have to write in that scenario, and you have to write only those instructions into the finally block, that instructions if you want to execute at any cost. Okay, whether exception generates or whether exception will not generate. So the combination is like this: try, catch, and finally. So when catch block will execute if exception occurs, then catch block will execute. If exception will not occur, then catch block will not execute, directly finally will execute. If exception occurs, then from the try catch will execute, and from the catch finally will execute. So the sequence is like this: try, catch, finally. You cannot write try, finally, and catch. This is error. You can write a multiple catch: try, catch, catch. So I will show you cascading. Okay, so I will show you the next. Yes, this one. So cascading exceptions and multiple catch blocks. Look at This is a try block, multiple catch block, catch, 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 catch. This is okay. Okay, and here within a try you can write a nested try also. This is also possible. And if you are not providing catch, outer catch block will support for the inner try block. Okay, so it works. Now here look at, after try multiple catch blocks are written, and just please check it: null pointer exception, runtime exception, IO exception, exception, throwable. Every catch block having specific type of error handling mechanism. That means every catch block having specific exception object. And at the last, look at catch is a throwable T. What is throwable T? Throwable T is a super class for all exceptions and errors. Exception is a super class for only checked and runtime errors. IO exception is a checked exception. Runtime exception is the runtime exception, that is unchecked exception. Null pointer is also unchecked exception. So look the sequence of the catch block. This catch block is a specific one. This is the specific one. Now this is checked IO file handling related. This is now generic one for runtime, and this is more generic one. So we are going an approach bottom up. Specific catch block first and then generic one. Why? Because in this code, suppose any exception occurs and it will throw. So if you just write directly throwable catch block here, if any type of exception generates here, throwable class can handle it. Why? It is a super class. Super class can hold the object of subclass, right? And if you write a directly throwable catch block as at a first level, so definitely other catch block will not execute. Okay, and in that case, throwable can handle your any type of subclass object, and this concept is known as upcasting. Okay, so here runtime polymorphism works and upcasting works, and other catch block is useless catch block, and that's why Java will not allow you to do like this. So if you want to provide a multiple catch block, go specific catch block and then generic one. Is it okay? Okay, so the sequence is try catch block, try multiple catch are possible. Only thing is specific one. So in the diagram, look here. So it's like this. Suppose you want to write a multiple catch block, so you go with a bottom-up approach. So first you can go with the null pointer exception, then you can write a catch block for runtime, then you can write a catch block for exception, then throwable. If you are not sure which exception will generate in my code, in that case you can write multiple catch blocks. Or if you are not happy to write the multiple catch block, in that case you directly write the super class catch block. That means supermost, that is exception. Okay, it is more appropriate. So only single catch block also works, and exception and the variable, and then you can go with the error message. So their exception, this class can handle any type of checked object or unchecked exception. So, and we are not dealing with the error, so no need to write the throwable, okay, or error. So we can happy with the exception. So try, catch. So most of the books you will get the code try and catch, and within a catch you have an exception class object. So why exception class object is there? Within a try, it may be any type of error will generate. That in that case, exception catch block will handle your any type of error, because it is a super class for all checked as well as your unchecked exceptions. Okay, and that's why it is a it can capable to handle any type of exception. Okay, and finally is used to deallocate the non-Java resources, or the code which is you want to execute at any cost, whether exception generates or not generates. So now the final sequence. How? Try, within a try, only you have to write the code where there is a possibility to generate an exceptions. Then if error occurs, then catch block will handle. Rule to write the catch block is, if you are exactly knowing what type of exception may generate, that catch block you can write it. If you are not sure, you write exception class and e object, that is generic catch block, super type catch block. And after catch you can write a finally. Within a finally you can write the code which you want to execute at any cost. That specifically which code you have to write in a finally is, my recommendation or Java tells you is, you have to write the deallocation of the non-Java resources. Only those instructions you have to write a finally. Deallocation of non-Java resources means deallocation of the resources which is not related to your Java program, which you are using into the Java program, external resources. That means file handling object opening, that is a closing instance, database connection closing instance, multi-threading related closing instances if there is any. Okay, so these abort operations you have to write in a finally, and after that the remaining code. So don't write whole code in a try block. Now what is use of try block? Try block is the error detection and error reporting. So try block is used to error detection as well as error reporting. Catch block, if any error occurs, the detected error is reported with the help of try, and catch will handle that error. Then and then only catch will execute. If any error is not detected and reported, then catch block will not execute. And finally, it is used to deallocate the non-Java resources. Another instruction you have to write outside the class. Okay. Suppose integer I is equal to 10, integer j equal to 0, and float equal to I divided by j. This is common your problem. System.out. Println. This is the result, right? So I just want to mention here, so before exception, and this is result, and this one here after exception. Okay, now I just try to execute this code. Look at, so it is showing you error, and before exception executes, look here, so it's like this. So here declaration, there is no problem, this statement gets executed. At the time of mathematical evaluation, it is your exact problem. So this is which type of error is, and here error generates and it throws to the JVM, and JVM will identify that type of error and it shows you the on screen arithmetic exception, and it is coming from the java.language arithmetic exception, and the error description is divided by 0, and this is available in test mypack in a main method, and the source code file is testpack.java and line number is 11. So here is the exact problem, correct? And after that error reports to the JVM, JVM will print the error message. After that, whatever instructions are available, it is not executed. Okay, so it is aborted. So what we have to do it, we have to provide the try catch block, correct? So because we want to execute the flow of execution, and here, so catch, and go like this within a catch. So which type of error is arithmetic exception, and obj, and here you go like this, obj dot print stack trace. This is the popular method where it will print the track of your exception. Again, save the code. So result variable we have to declare outside. So we will do this. You can declare outside. Let's run the code. Check the again. Here before exception, exception generates. It is okay. Divided by 0. But after that, look here. After exception block execute. That means flow of execution is continued after exception also. Okay. So you write print ln. So whatever exception statements are available, your instructions are available, that will execute. Look it. So all statements will execute. Look, java.lang.arithmetic divided by 0. This is exception. Still your instruction gets executed. Is it okay? So why we deal with the exception handling? If you want to handle the runtime errors and continue the flow of execution. Okay. Okay. And same problem, line number 12 having the problem. It is specific one. And suppose you don't know what is the exact the exception try block is there. So catch block is there. So you go like this. Exception. It works. Okay. Look. Same output. Arithmetic exception. Here you are using exception. Still it is showing you arithmetic exception. Why? Because here object is thrown and that object is a type of arithmetic exception. Arithmetic object is pointed with the help of exception class. Exception is superclass. An exception superclass variable obj and object is arithmetic exception. It is your upcasting, right? And then here at a runtime print stack trace gets called, but print stack traces gets called from exception class or arithmetic exception class. It is from the arithmetic exception class. That's why it is showing you. So it is a runtime polymorphism. Are you getting? So this is important. So how it is maintained. And if you want to write a generic, if you want to write a multiple one, so you go like this. It also works. So and here you have to go with the first specific one and then generic one. Is it okay? Now check. Run the code and which now exception block will work? First one. I will say you write one SOP statement and check it because it is specific one. This will not work. Is it okay? So it is a sequence, try, specific catch block, then generic, okay? Is it okay now? Next lecture we will see more examples on this, the different scenario. Okay, so I stop here.